Okay, welcome to another Orbiter 2010 video, and this video is going to be a continuation in the Jupiter moon hopping series that I'm doing, where I'm starting off on the farthest moon from Jupiter, then hopping down one moon at a time until we ultimately get to Io. In this part of the hop, we started off on Europa, and we're on our way to Io. And in this one, I actually remembered to start thinking about the base alignment before I ever did the ejection burn, and I forgot to do that on the first two hops. But unfortunately, it didn't really do me a lot of good to remember to do that because I had just a lot of problems figuring out exactly how the burn was going to work. I couldn't make it work. In my opinion, there's always a solution, but it's just a matter of having enough time to do it. And I backed up the clock by 3 or 4 minutes at one point, and I didn't want to keep doing that because the video just gets a little too long and boring. I'm sure it already is, but anyway, so I gave up and just decided to go for the lowest, to go for the target PEA that I want at Io. And when you're going from moon to moon, you don't really want to necessarily aim for the center of the object of the body like you do when you go from Earth to Mars. You want to set when you go from Earth to Mars, you want to set your PEA at Mars to 2,500 kilometers below the surface or something like that. But when you're going from moon to moon, you don't necessarily want to do that. You want to aim closer to the surface, maybe 100 kilometers below the surface or something like that. So let's go ahead and switch camera views here, and we're going to warp time forward. And before we get too far along, we've only got a little over a day to go. It's 98,000 seconds. So that's 86,400 seconds is one day. So just a little over a day between here and our arrival at Io. So before we go too far out, we're going to start thinking about trying to get this base more aligned, because our angle currently is 55 degrees and it's getting worse as we go forward. But perhaps once we break away from the hold that Europa has on us, then things will get a little bit better. So let's find out. Let's bring up Orbit IMFD and let's just warp time forward. Now what I like to do is warp time forward until I get around to the retrograde position. In this case, we got out of Europa's SOI so fast that that we're now showing orbit Jupiter. But I like to get to where I'm basically where I can see the object that I'm leaving. Then I'll kill rotate, and now I can warp time forward at say 10,000. But let's go to I don't really know. Let's just pick 60,000 as our target PET. So right about here. We should be, according to Orbit MFD, Europa has no hold on us anymore, even though it's right there. We're not very far away from it, but Jupiter is such a beast that it's the dominating force now for sure. But let's see what we can do about this angle, because we would really like to arrive at Io and have our angle to the base be much closer than, 54 degrees, because if it were 54 degrees, and then we got into orbit around Io, we would either have to do a big base alignment burn, which would cost a relative fortune, or we would have to orbit Io a very, very long time, because it only rotates at 74 meters per second, so it would take a ton of orbits before the base passed underneath of our orbital plane. All right, so I'm going to go prograde just so that I'm facing some direction that makes sense. Turn off prograde. And I don't really know what I need to do here, so I'm going to bring up interplanetary on this side, and we're going to come out of the burn vector. And we're going to just start, so we're going to set up a maneuver. We're going to kind of do what we do in Transx. A page over here, turn on the plan, and I'm just going to start putting in different amounts of velocity just to see what will happen. But the first thing we need to do is kind of reset the previous stuff, so we'll set that to 0. And we want to set the time to the future because we can't do the maneuver this very second. So let's give ourselves 360 seconds to set this up. Actually, also, we need to reference the correct body. Reference Jupiter and target Io. So we need to make sure that that's correct, because otherwise when you're setting up your plan, none of the stuff that you see in Map MFD is going to make any sense. So and then that reset the TEJ, so we're going to have to reset that back to the 360. And now we can start playing with different variables here, but I don't think we're going to need prograde necessarily. So let's see, first of all, what plane change does. And positive plane change is not doing anything. And it's having such a small effect that I don't think it's going to help. So let's try inward outward. And positive inward is making that worse. And negative is bringing the PEA down, and it's bringing the angle down. That's a little bit more effective than plane change, but let's see what forward and backward does. That's having a big impact. Okay, let's go with that. Actually, no, it's not. It's having almost no impact. So it looks like inward outward is what we want to start with, so we'll set that back to 0. And I believe it was a negative. Yeah, negative. Okay, so negative is bringing down the angle and it's lowering our PEA, so that's okay. We'll just have to... And we may not want to do this maneuver right now. We're saying that we're going to do the maneuver in 280 seconds, but it may be better, it may be cheaper to do it a little bit later, so we'll see about that here in a moment. Okay, we've almost got the angle down to 0, but now our PEA's out a bit. So let's check here into, say, plane change, maybe. Let's try forward, backward first. So a little bit of positive, that's helping to bring the PEA down, and it's raising the angle a little bit. Okay, so, but let's see if we do this a little bit later on. That's not what I meant to do. Actually, I guess I can't really tell if it's going to be cheaper later. We're here. And in theory, the cheapest time to do this would be when we're 90 degrees away from IO, I think. And that's about where we're at now. At least 90 degrees away from the target, I mean. So, and that's about where we are now. So let's try this. Let's reset. Let's just go forward a little bit farther. Let's go to... Turn the plan off for a moment. Let's go to like 55,000. And these are just kind of guesses on my part. Now let's turn the plan back on. And now let's set this to 360 seconds. And see if we can do this a little bit cheaper at this point. So add in some DVI, in other words, take out some of the... And actually it's worse. So we should have went with what we had before. Actually, page selection. Okay, so we're just going to have to do this maneuver now. It's going to cost us a little bit more than it would have a few seconds ago, so we should have done it. We should have done it 5,000 seconds earlier, but that's okay. PEA, let's bring it up a little bit. That's a little low. So taking out some of this prograde. That's fine. Although it's trending down, so let's actually do that. And now let's check the DVI. Okay, that is trending which direction? Yeah, we don't know. Okay, so we'll go with that. Just put in there to get it exactly to 0. Now we'll page over and burn this maneuver. Warp time forward. And at 180 seconds it'll orient the vessel. Back to real time for a moment. Let me page over, since I noticed that change just ever so slightly. Still got a few seconds here. We can play with it if we want. Turn off the burn vector. And we'll leave it right there. Okay, warping time forward, and we'll do the burn. And that should get us lined up. So it's going to cost us an additional 105 meters per second. Probably could have done that a little cheaper if we had somehow figured out how to do it as part of the ejection burn. But I think we would still have some kind of mid-course correction to make anyway. Burning now. Turn the plan off. Have translation ready to go. And there we are. PEA is 40 kilometers, but going down, and the angle is just, it's right on. I don't really want to, you can, if you want, try a little bit of translation one way or the other to see if you can bring that all the way to 0, but it's total guesswork. I don't know which one to use, so it'd be a waste. So let's go forward until PET is about half that number, so about 30,000. Then we'll check in again and see how things look. Okay, there we are, about 30,000. See our angles slip just a little bit, and the PEA's come down about 19 kilometers, I think. Wasn't it 39 before, or was it 31? So with a little bit of translation, I can maybe bring that back to 0, but it's just guesswork. I don't know which one to use. So that's not doing anything. So a little bit of, I'm pressing 2, but considering my orientation, it's a combination of several different motions. So now we've got the angle to 0. PEA is fine. It's actually, it'd be perfect if it would stay right there. Now it's going up a little bit. So let's go forward until PET is at least half that number. Let's go 15. And let's see how things look. Angle's good. PEA is good. See if we could do just a little bit more correction on the angle. I think maybe if we go to here, just overshoot it a little bit, it might be better because it seems to be going farther into the negative as we go forward. But we're getting so close now to IO that our plan, that IMFD should be pretty good, pretty accurate. In fact, IO is right there. Okay, we're certainly done with maneuvers. We're not going to have to do anything else. Let's bring up map. IO is already referenced for some reason. Make sure the orbit plane, make sure the orbit lines are set to orbit plane. And we don't have an orbit line around IO. We won't have till we're much closer. Let's bring up orbit MFD, reference IO. Copy that info to the HUD, and we have a gravitational influence from IO of 0.01 and PET 15,000. So let's go forward. Angles dancing around a little bit there, but should be okay. PEA is holding pretty close there, around 30 kilometers. I'm happy with that. Getting a little bit closer to IO. Okay, we're only 1,000 seconds away from lowest point of our orbit, so let's check things out. This is a texture that I downloaded for IO. It's called like IO with volcanoes or something. I'll put a link to it in the description if I remember to do that. Rotation. Okay, let's rotate around. We're going to be retrograde to do the braking maneuver, obviously. So let's get to the retrograde position now. And there's a couple of ways to do the braking when you get to the body. I'm going to see if I can do the easier method. I'm not sure if I'll be able to because Jupiter is so massive that its gravitational influence may confuse IMFD, so we may have to do the more, the less easier method, but let's see what we can do. Also, since the angle's a bit off, let's see if we can fix that before we get in any closer. That's the wrong direction. That's unfortunate. So a little bit of up translation, out of the top. Bring the angle back down to 0. And the PEA is fine right there. Right around 30 kilometers is exactly what I want. So that's fine. Now, how close are we? We're still a little bit out. Let's get closer. Okay, so we are going to have Io as the dominating gravitational influence. I wasn't 100% sure. I was thinking we would, but I couldn't remember. Again, when you're on Saturn, several of the moons of Saturn are so small that even when you're on the planet or on the surface of the moon itself, the dominating gravitational influence is still Saturn. Let's get closer. All right, now we're going to bring up interplanetary IMFD on this side, and there's an easier way to circularize your orbit using one of these programs. I just have to remember which one. Okay, menu, not orbit eject course, menu, orbit insert. I think it's orbit insert. I think when you use orbit insert, it's like completely automatic, so you don't have to figure things out on your own. When I did the IMFD training videos with Dimitri, we used a different method for circularizing when we got to the moon, and it turns out that that's fine. It works perfectly. You can do it that way. But if you can use the orbit insert program, and you can't always use it, but if you can, then you want to, it's a little bit easier. Make sure that the body that you're going to is referenced. Again, we're going to Io, so we're referencing Io. I guess the source probably has to be us. That makes sense. And this is basically completely automatic. You don't have to set anything up. You just page over and just do auto burn, and then when it's time to circularize, it does it. That's why it's easy. But there are some things you can take into consideration, like do you want to circularize based on eccentricity? Do you want to circularize based on a specific target apoapsis? Or do you want to circularize based on the major axis, which we're definitely not going to do that. Or you can say, I want my orbit period to be a certain fixed amount. Probably in most cases we want to circularize based on eccentricity. I think I said apoapsis in the last one, but I think circularizing based on eccentricity is actually best. So in other words, we're going to get to our PEA of 28.47, and then it's going to circularize based on that. So our PEA and APA will be the same. If we circularize based on apoapsis, then we're going to get to our periapsis of, say, 28 or 5 kilometers or whatever our periapsis is, and then it's going to set our apoapsis to whatever we set it at. So like if we have apoapsis here, and I set the APA to 50K, then I'm going to have my periapsis is going to be this number, 28.48. My apoapsis is going to be that number. In some cases, that might be preferable, but in this case, I think what I want is to have a circularization based on eccentricity of 0, 0 ECC. All right, let us warp time forward and do the circularization. I'm going to bring up map over here. Yeah, we've got our orbit line now. So you can see we're passing right over top of the base. So our planning from the ejection burn from Europa over to here was good. It cost us some fuel to do that mid-course correction, and I'm sure there's a way to avoid that. But that's for somebody smarter than me, like Dimitri. Okay, burn's almost complete. Let's actually look at the burn vector. Let's also look at orbit MFD. Okay, there we have it. We got a periapsis 27 and a half and a apoapsis close to 29, so pretty circular. It's not perfectly 0 eccentricity, but it's close. Certainly close enough that we can go ahead and land now. Now we are 2,200 kilometers away from the base and getting farther away, so we need to go around to the halfway point and do our deorbit burn to bring down the other side of our orbit. We're done with interplanetary MFD. I can't think of any reason to use it anymore. But let's bring up base sync, and target IO base and change this mode to direct, which we need. Going to set the number of orbits to 1 because we want to land pretty much right away. Now we do have some difference in our off-base distance. Our angle, even though it said it was 0.00, there must have still been, some additional decimal points there that we couldn't see, so our distance isn't quite right. But we are coming up on a node right now, so we can actually do a corrective burn. But the thing is, I typically find, at least on Earth, because of Earth's rotational velocity, you don't really want to do the base alignment correction until after you've done the deorbit maneuver. That's because when you do the deorbit maneuver, it's going to have some impact on your distance off base due to the rotation of the body. Now, Io rotates much slower than Earth, but it still has a rotational velocity of like 73 meters per second. It's actually in my document. It has a rotational velocity of 72 meters per second, roughly. So that means if we do the base correction here and bring the distance down to 0, then when we come over here and do the deorbit, it's going to have a change here by some amount. It probably won't be a lot, but it'll be something. So I guess what we can really do, let's go ahead and bring the distance down a little bit. Let's bring it down to, say, 10 while we're here. Then we will deorbit over here. Then we'll do any final base alignment correction at that node.
Rotation.
Okay, coming up to the node in just 24 seconds, and according to this MFD, we would need, I am targeting IO base, yes, because the latitude and longitude. We would need a 1.3 meter, 1.3 second burn using the full power of the main, but we're not going to do that.
Translation.
So we'll just put in a little bit of down translation here. And we'll bring that distance down to, we'll just bring it down to 20 because this is going to take a while using translation. Then we'll go over to the halfway point and bring down the other side of our orbit. All right, that's good enough there. Now watch what happens when I come over here to the opposite side. And what I'm going to do is I'm going to watch the distance counting up. I'm actually not looking at apoapsis, but I'm looking at the distance counting up. When it stops counting up and starts counting down, then we do our deorbit maneuver, or lower the other side of our orbit. And that's going to be about when this is all the way across. Okay, we're getting close to that point, so let's go retrograde. And turn retrograde off, save a little bit of that fuel, because we're not quite there yet. Beautiful view of Jupiter back there on the horizon. Go a little faster. Now we're almost halfway across. And it won't be exactly halfway across in most cases because you're not going straight across the equator. There's going to be a little bit of inclination to your orbit, so it's never probably going to be exactly halfway across when you do the deorbit. See, we're a little bit past, and it's still counting up. Still counting up. We're actually quite a bit past that halfway point. Now we're counting down. So back to real time, retrograde, and we'll bring up orbit MFD over here. Actually, wow. Because of Jupiter's strong gravitational influence, it's perturbing our orbit so much that it's really throwing our PEA off. You can see, we started with a PEA of 27 or something, and it's already down to 7, so we don't really want to lower it too much. In fact, I'm only going to lower it a little bit just so I can show this distance thing that I was talking about. I'll bring it down to like 5. But you'll see as I'm adding in, as I'm adding in thrust to bring down the PEA, it's having an impact on our distance. And that's why if you bring it all the way to 0 here, then when you get over to your point where you do your deorbit or lower the other side of your orbit, when you do that maneuver, it's going to change your distance. But when you do the base alignment here, there won't be any farther impact on your distance off base because you have no more burns to do until you do the actual braking burn over top of the base. So let's go forward now to this node, and we're 1,000 seconds away from that node. Watching the PEA, should have brought it down a little bit more, but I just didn't know. This time we require about a 1 second burn using the full power of the main engines, but what we'll do is we'll just use the hover engines because we're facing, instead of bothering to rotate up and then use the main engines, we'll just hover. And that's only going to take about 2 seconds maybe. Okay, there we are. And hover. Okay, there we go. And I think I overshot that a little bit, but it's okay because you can see it's the direction that it's trending is working out in our favor. It's getting closer to 0, so that is fine. All right, so now we're all set up. We are ready to land at IO base, and then that will be the end of this series. We're at 26 minutes though, so I'm going to go ahead and save the landing for the next video, even though the next video probably won't take more than a few minutes, but we'll go ahead and save it for another part just so that this video is not too long. If you like this part of the video, like it. If you didn't like it, don't like it, leave comments down below. And if you have any thoughts on things that I can improve, do better, let me know. I always read all those types of comments. And check for links in the description below. Again, I've got a Facebook fan page where you can check that out. I post all my videos there. Post other pictures, space-related content, stuff that you don't necessarily get to see on my YouTube channel. And I've got a FAQ, which frequently asked questions, things that people ask me a lot. So if you want to kind of browse over that, you can check that out as well. I've got my computer specifications in there. I've talked about what kind of joystick I use and all that type of stuff, what video recording software I have, and just a lot of other Q&A type of things. So check that out, and I will see you in the next video. Okay, welcome to another Orbiter 2010 video, and this video is going to be a continuation in the Jupiter moon hopping series that I'm doing, where I'm starting off on the farthest moon from Jupiter, then hopping down one moon at a time until we ultimately get to Io. In this part of the hop, we started off on Europa, and we're on our way to Io. And in this one, I actually remembered to set up to start thinking about the base alignment before I ever did the ejection burn, and I forgot to do that on the first two hops. But unfortunately, it didn't really do me a lot of good to remember to do that because I had just a lot of problems figuring out exactly how the burn was going to work. I couldn't make it work. In my opinion, there's always a solution, but it's just a matter of having enough time to do it. And I backed up the clock by 3 or 4 minutes at one point, and I didn't want to keep doing that because the video just gets a little too long and boring. I'm sure it already is, but anyway, so I gave up and just decided to go for the lowest, to go for the target PEA that I want at Io. And when you're going from moon to moon, you don't really want to necessarily aim for the center of the object of the body like you do when you go from Earth to Mars. You want to set when you go from Earth to Mars, you want to set your PEA at Mars to 2,500 kilometers below the surface or something like that. But when you're going from moon to, so right about here, we should be, according to Orbit MFD, Europa has no hold on us anymore, even though it's right there. We're not very far away from it, but Jupiter is such a beast that it's the dominating force now for sure. But let's see what we can do about this angle, because we would really like to arrive at Io and have our angle to the base be much closer than 54 degrees, because if it were 54 degrees and then we got into orbit around Io, we would either have to do a big base alignment burn, which would cost a relative fortune, or we would have to orbit the hold that Europa has on us. Then things will get a little bit better. So let's find out. Let's bring up Orbit MFD, and let's just warp time forward. Now what I like to do is warp time forward until I get around to the retrograde position. In this case, we got out of Europa's SOI so fast that that we're now showing orbit Jupiter, but I like to get to where I'm basically where I can see the object that I'm leaving. Then I'll kill rotate, and now I can warp time forward at say 10,000. But let's go to I don't really know. Let's just pick 60,000 as our target PET. Moon, you don't necessarily want to do that. You want to aim closer to the surface. Maybe 100 kilometers below the surface or something like that. So let's go ahead and switch camera views here, and we're going to warp time forward. And before we get too far along, we've only got a little over a day to go. It's 98,000 seconds. So that's 86,400 seconds is one day. So just a little over a day between here and our arrival at Io. So before we go too far out, we're going to start thinking about trying to get this base more aligned, because our angle currently is 55 degrees and it's getting worse as we go forward. But perhaps once we break away from the